Section 4-2, standard form of a quadratic function. Standard form is f of x equals ax squared plus bx plus c. If a is greater than 0, then it is going to be a minimum, which means your parabola opens up. If a is less than 0, it's going to be a maximum, and your parabola opens down. To find the axis of symmetry, you need to memorize this little formula, x equals negative b divided by 2a. To find this is also the x part of the vertex. So that formula is going to give you the axis of symmetry and the x part of the vertex. To find the y part of the vertex, you are going to take what x equals from the axis of symmetry, and you are going to plug that value in for x into the given equation. And then the last thing you need to find is what the y-intercept is. And to get the y-intercept, it's the point 0, c. When you are graphing parabolas that are in standard form, you need to graph the vertex, you need to graph the y-intercept, the axis of symmetry, and then you are going to graph a point of reflection. Okay, and you're going to take the y-intercept and you're going to reflect it across the axis of symmetry. So our first example is y equals x squared minus 2x plus 4. And in the very beginning, it might be very helpful for you to identify what a is, what b is, and what c is. So a is the number in front of x squared, so it's positive 1. B is in front of just the x term, so it's negative 2. And c is the number all by itself, so it's positive 4. So always, your first step is going to be to find the axis of symmetry. And to find the axis of symmetry, we use that little equation, x equals negative b divided by 2a. So negative 2 makes it positive 2 on the top, divided by 2 times 1. 2 times 1 is 2, and 2 divided by 2 gives me x equals 1. So my axis of symmetry is x equals 1. Remember, this is also the x part of your vertex. So now to find the y part of my vertex, I take what x equals, and I'm going to plug it in for x into my original equation. So I'm just going to write over down below. So y equals 1 squared minus 2 times 1 plus 4. 1 squared is 1, negative 2 times 1 is negative 2, and then bring down your plus 4. 1 minus 2 gives me negative 1, plus 4 gives me a y value of 3. So my vertex is at the point 1, 3. And then we need to find your y-intercept. The y-intercept is 0, c, and c in this problem is 0, 4. So we have the 3 things that we need to start our graph, so let's draw it over here. So 1, 1, 2, 3. I know my parabola should be opening upwards because a is positive. Graph 0, 4. Draw the axis of symmetry. Okay, and then we need a point of reflection, so this distance from here to here is a distance of 1. So on the other side of my axis of symmetry, I am also going to go a distance of 1, and then you make your parabola. Okay, I also need you to tell me what the domain is. Remember, that's never going to change. It's negative infinity to positive infinity. Now the range, since A is positive and your parabola is opening upward, the lowest part of your graph is that y value of your vertex, so it's 3. And then it's never going to stop growing upward, so it's 3 to infinity. In example 2, press pause, and I want you to graph y equals negative 2x squared plus 2x minus 5. So in this problem, A is negative 2, B is positive 2, and C is negative 5. So we need to start by finding our axis of symmetry. So x equals negative b, so it's going to become negative 2, divided by 2 times a, which is negative 2. So that's going to give you negative 2 over negative 4, which is going to simplify to x equals 1/2. So my axis of symmetry is x equals 1/2. That is also the x part of your vertex, so we can go ahead and we can write that in.